So, I'm Romeu. I work with for a little company called Aurora, and I do love property-based testing. My hope in this presentation is by the end of the presentation, you are ready to do property-based testing in your day-to-day job, in your code base. So most of you have legacy code bases, right? Right? Yeah. And most of you have to deal with shitty code at some point of your life. Not now, of course, but at some point in your life. So whenever people, I created this talk because I cross people doing looking at property-based tests really quickly. They see quick check or something like this, and they say, "Well, that seems nice and all," and they go to a tutorial, and the tutorial they find, they just see, well, it shows that an addition is commutative, and or the addition is associative, and they say, okay, this sounds nice, this sounds mathematical, I don't need that, I don't do this in my daily job, and they just close it and they don't do anything else. Yeah? So my hope is to show you that in real life, properties are all around you. You are literally drowning in properties that you can use in your day-to-day job code base. And properties are awesome to use when you have a legacy code base. I mean, when you have really, really shitty code, properties will help you remain sane. And I mean, I'm not saying I'm sane, but it will help you remain sane, okay? So, property-based testing is just a fancy name to say we use entropy to test our code base. Actually, it's a bet. A property-based test is a bet. You think you have a property, and the framework tries to prove you wrong. Okay? So what is a property? We just told, our working definition we chose just before is something that is always true. So you see your code base, you see something and say, oh, this should be always true. Okay? You have this idea, you say this should be always true. And the framework tries to prove you wrong. That's the basis of it. Tries to find a counterexample by randomly shoving inputs. Yeah? It's a bet. Property-based tests are a bet. It's like an insurance company. An insurance company it's just a casino. It's just a company that does bets. You bet every month that your house will be on fire, and they bet that your house will not be on fire. They win, and you're happy. Yes? Property-based tests are the exact same thing. You bet that your program has a behavior, and the framework tries to bet that he can find a counterexample to that. And he fails, and you're happy, or he finds, and you're happy. Right? Property-based tests bring happiness. So, let's start with a normal test. Well, I don't know why do I have this screen here. Let's go there. Yay. So, have you ever done a kata? Who here has ever done a kata? You know what a kata is? Okay, and it's a little exercise we do. It's not very important what a kata is right now. It's an exercise, okay? There is a kata that is about doing the bowling score. Who here has ever played bowling? Okay, so not everyone. I will just try to give you a little rundown of what bowling does. When you play bowling, you throw a ball into some pins, yes? And if you have to calculate the score of a game, you have this concept of a frame, yes? So at each frame, you can throw two balls. You have two tries to make the pins go down. And you have a point for each pin that goes down. And your score for each frame is how many pins went down. And then at the next frame, you have 10 pins again, and you try again. Okay? Well, there is some special cases when you you manage to put all the pins down. If you took the 2 balls to do it, like 3 and 7 or 0 and 10, right? You took 2 balls to do it. Then you do a spare, yeah? Okay. When you do a spare, the score for the frame is 10 plus the next ball. So if I do 0 and 10 and 1 and 0, what is my score? 12. 12, right? The first frame is 11, and the second frame is 1. Yeah? Okay, and then you have this other dream state where you do a strike. Your first ball touches all 10 pins and puts them all down. Yeah? And you did a strike. When you do a strike, your frame is 10 plus the next 2 balls. Yep. No, not plus the next frame, plus the next 2 balls. Because if you do 3 strikes in a row, right? So the perfect game is you only do strikes, right? It's 300 points. Okay, so if you were to do this in TDD, if I ask you to do the bowling score as an exercise, and you do it in TDD, you do example-based testing. You start with a first test, right? And it will be something not completely unlike this, right? Can everyone hear this? We start with a, oh yeah, this presentation figures very bad names. This is not a coincidence. I made it on purpose. I don't want you to look at the names of the methods. So they're all awful, okay? So, here I start with, oh, I did no points at all, right? And I should have a score of 0. This is a first test, yep. This, by the way, is a score I already had in real life. And oh yeah, why am I doing this in Java? We are ScalaIO, right? I have a very serious reason to do this in Java. A very, very serious reason to do this in Java. In Java 6, precisely, because I'm doing this in Java 6. I'm doing this in Java 6 to show that you can do it even in shitty languages. You have no excuse. So in Scala, you have this very beautiful thing called Scala check, which is probably the best framework for property-based testing in the whole GVM. Okay? By probably, I mean, yes, it is the best framework for property-based testing in the GVM by far. So what I'm trying to show you is, if you're not doing Scala here, if you love Scala but not doing Scala here in the day-to-day, and you have some cheaty language that you have to use, like Java 6, right? I'm not saying Java is shitty, but Java 6 is shitty. Yeah? Also Java, also Scala. All languages are shitty. There are no good languages, but this is another topic for conversation. And so, thing is, what I want you is to understand that even if your code base is awful and your language is shitty, you can still do, and you should probably do, property-based testing. Yeah? Okay. So, let's go back. If I will start doing TDD, I will do a first test like this. Then my solution code, what would it be? Return 0, right? That's enough. And then I do a second test, and we do it like this for a while. Yeah? Okay. And so I will probably do a second test where I would put still a very bad name. And where I'll put, oh yeah, if I have some singles, I'll just put some addition here and this is the sum. Yeah? And then something, I'll try a spare, and I'm not, oh yeah, if this should be 11, this should be 12. And this, I have several spares, a more complex strike, and have a strike, a more complex strike. And we end up with the perfect game, which I never had in real life. And thing is, once I did this, I'm kind of in assurance that I have a pretty idea of what my test cases are, yeah? I have a set of, I did this in TDD, so I have a set of tests that go over what my code is supposed to do. Do everyone agree with this? Okay, just a quick question here. Raise your hand if your tests in real life, in your code base, resemble this. You liars. You are lying to me. You are lying. Your tests in your real code, I know you. In real life, your tests are much more near this, yeah? Does this ring true? So, this is a copy I made of a test from just a simplified version of a test I had in the client. He gave me permission. Thank you, Vidal. And and the thing is, this is much more close to what you have in real life. Yeah. You usually don't have tests that are so sparse in lines and so elegant and minimalistic as this bowling cutter, and you don't have them because you have real problems and not a small thing that you can do in a single way. Don't hate on this. It just means that you have some complexity in your code base. That's normal, yeah. But you still have a problem here. Okay, so I'll go back to this later. This was a parenthesis. We will go back to the bowling test and go over property-based testing with it. But then I will go back to this and show you how to do it in real life. Yeah? We have a problem with this test. I think it's obvious to everyone that the only line here that matters is this one, yeah? Everybody saw that? Yeah? No, right? You didn't. But the problem is we are creating, we have to test something that needs a prescription, so I have to create a prescription, but to create a prescription I need this, and to create this I need that, and to create that I need this, etc., etc., etc. So I creating objects that I put in objects, 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 to call something, and to check the result, I make an object that I put in an object, etc., etc., etc. And thing is, I mostly don't care about most of those values, yeah? There are values I put there because I needed them to create my objects, but they are not important for my tests. Now, I could do this better, right? This is not the best way to do this. I could at the very least, I could put a comment saying, this is the important one, or separate the lines somehow, yes? That's the very minimal thing I could have done. I could have named it better my test also. That's a very good thing I could have done. I could have created fixtures. Yes? I could have created fixtures elsewhere. That's also a thing I could have done, etc., etc., etc. All those things, we will come back to this, but all those things would make my code less ugly, more beautiful, yeah? But it will not change the underlying problem. The nature of my test would still be this. If you do all those things, you still have this somewhere, yeah? I'm not dissing on beauty. Beauty code is very important. Beauty in code, like in flowers, is there to ensure the means of reproduction. You should seek beauty in code. But I'm not saying beauty is bad. I'm just saying that here, it doesn't change the essence of my problem. Yeah? Okay, let's go back to bowling. So, this is a test not completely unlike those you have in real life, just simpler. Yeah? I have problems with this test. What problems do you see with this? It's not exhaustive at all, yeah? It's not exhaustive. This is a problem. I mean, I guess I could do all permutations of input here, right? Bowling is kind of small, but at some point you can't, right? Being completely exhaustive is difficult. What I mean by this is, we created example-based tests, so we create tests that represent a larger area of things. So here, this represents all tests where I just do some single points, yeah? And if it worked for one, it should work for others. Yeah? But then if it doesn't, I don't know. I have no feedback. Yeah? But you will not write by hand all possible combinations, so it's kind of a deal we accept every day. Yep. If you do tests at all. Who does tests at all? Wow. Who here develops and doesn't do tests at all? That man, you should. So, so once we did this, I have another problem with this test here. Another very strong issue. All of you, I did this on purpose. I have explained to all of you what are the rules of bowling. Yeah? Do you remember them? More or less. Now, suppose you don't remember at all. Suppose you have never played bowling. Suppose you have never seen a bowling game at all in your life. And you discover bowling through this code base. Now, I have not shown the code, the solution code, and I will not. Okay? In most code base, and not yours, of course, but in most code base, the tests are in the domain of problems, and the code is in the domain of solutions. Yeah? Or if I put it less poetically, the code just describes the solution to a problem that is never described anywhere else ever. Yeah? A problem long lost. You wanted a hole, so your code describes the engine to a drill machine. Yeah? And that's all the code does. And now you, with this code there, and you try to discover what was supposed to do, what this was supposed to do. Yeah? It's a struggle you should have every day in every code base, really. Do you know all your business rules? Have you read all your code? Do you know what are all the business rules that are implemented in your code? Anyone? Right, no one, yeah? Actually, several years later, you see your code base. And even if you did every line of code, several years later, you see your code base. And when you look at some line, you just don't know completely if that line of code there was just a mistake by a newbie programmer or represented an edge case of a business case. Right? You don't know. You have no idea. Yeah? Right. So wouldn't it be good if you could ask questions to your code base, right? The code base knows business rules that you don't know, and your business people don't know. They're just there. Would be awesome to ask the code base those questions, yeah? By the end of this talk, we will be able to. So, thing is, when I just look at these tests and try to think that you are discovering bowling by reading those tests. Because you do this all day, really. You grab a piece of code in your daily job. You grab a piece of code, and you try to discover what was this supposed to do, and you discover a business rule by reading the tests. Yeah, that's what you do. And you try to archaeology your way to discovering the business rule by reading the tests. Try to do this with these tests. Can you discover the business rules of bowling just by reading those tests? Right? At some point, maybe, but it will take some time. Yeah? Yeah? Because I would have to read my inputs here and say, oh, and what does this mean? Oh, okay, so this seems like an addition. After some while, just with those two input points, I may be able to infer that usually my score is the sum of pens, but it requires some thought there to discover that rule, yeah? And yet I have tried to make things simpler for you, right? I tried to make an effort towards that archaeology. You see here, I put this sum here and this other here to show my spare, right? I was trying to help the archaeologist. Yes? I could just have put 12. I could also write a comment say, fuck you. But I try to help my archaeologist because maybe it's me, right? So I try to help. But thing is, maybe we could do better. Who here has ever done parameterized tests? You should all do parameterized tests. Parameterized tests are awesome. And if I had to do the same tests with parameterized tests, how would I do them? It would look like something like this, right? I could put all... A parameterized test is just a test that takes parameters, right? Now, I could have put all my inputs and outputs in my parameters, yes? I could have done that. But then, I'd like to think that I would have no benefit if I did such a thing. I hate putting all inputs and outputs in my parameters. I used keep... Sorry. I usually keep between all my inputs and outputs, at least one of them, one of the inputs of the outputs is fixed inside the test itself somehow. Right? And if I do this, because if I don't do that, I probably can have all my tests be a single test in parameterized testing and mean nothing, right? Like some years ago, when I had saw my very first parameterized tests, it was some... let's not talk about my age. And there was a company that did parameterized tests to do integration tests, and was a code that called a REST API, right? And they just put all the inputs and outputs into the test. And say, well, when I call my API with this URL, I should have this HTTP code. And they only had 3 HTTP codes, right? Several ones were 500 and something, several ones were 400 and something, several ones were 200 and something, right? Well, what they really had there was 3 tests, 3 parameterized tests. Each one of the tests should have taken just URLs, right? A test that say all those should work, all those should have a problem, all those should be missing. Yep. So usually I keep one fixed. So I did that with bowling here, binomial case. And what I told is, this is just my, this is just my 2 first tests here, right? Together. Okay. And also I added 2 new ones because one of the advantages of parameterized testing is that I'm grouping tests that means the same thing together, and now I can add some more just for the effect of it, to help my archaeology, right? And once I did that, something peculiar happened here. My assertion changed. I'm not saying anymore, oh, I want my score to be the sum of all the inputs. I want my score to be 12 or 11. I'm saying I want it to be the sum of all the inputs. Before I was saying my test was example-based, was for this input, I want this output. Input, output, input, output, right? Now what I'm saying is, for this input, I should have this behavior. Inputs, behavior. Inputs, behavior, yeah? The essence of my test itself changed when I did this. And now we are halfway to property-based tests. So, thing is, once I did this, you could argue that I started to put the answer, the solution into my test itself, right? I would argue that I didn't, but I chose this test exactly because there's a kind of a gray area in this very complicated one. That was the reason why I picked this, right? I argue that I could still have several different solutions that would pass this test, and that I'm not comparing my code to a test code that I created, but my code to a basis thing that exists on Java itself. And I should not test Java itself. Yeah? But I do understand people that think that here I crossed the line. It's a gray area. Okay? Your test should never, ever have part of the solution code. Don't do that. This, for me, is the nearest thing you can do, but don't go over this. Don't put solution code into test. Your code can have slices of solution and slices of problem, but your test should rely purely on problem space and never in solution space. Why? No, because if you test, he said because you don't test anything. No, you're testing something. You're testing a tautology. You're testing that a thing does the same behavior as itself. Right? But a thing has the same behavior as itself. You can trust me on that. Right? So you don't need to test that. This is a tautology. You never test a tautology. It's a waste of time. Right? So what I want to test is a property. So yeah. Okay, this is like I said, I could have several implementations for score, right? I'm not looking inside it. And yes, I have chosen this example because it's a very gray area one. I have no problems with people that think this is already crosses a line. Okay, if you think it, don't do that. Don't go at that point. Do less. Okay. My whole point here is that by mixing together tests in parameters, I have created a test that describes the behavior. And you have tons of things like this in your code base, where you can just describe the business rule in the test itself. But now if you want to do archaeology, it's way simpler, right? You can read this and you know what a score is supposed to do is the sum of the balls, and it is between 0 and 300, yeah? I have helped somehow my archaeology. It's not perfect. There are several problems with this approach. Do you see any? Well, it's still not exhaustive. Yeah, yeah. I have other problems. I still have half of my archaeology to do. I have the business rule here, but I still have to watch those things here and try to find what they have. Do they have in common? Yeah. And it's boring. I just reading this make me bored, right? I think that's very boring. I also have another problem here, but I have done this presentation like 25 conferences already, and only 3 people have found this problem until this point. All 3 of them were, and this is true, QAs. But 3 and 9 makes 12. This is more than the 10 I can have. And and the thing is, this was a problem that was already there. I was just trying to show you something. It was already in my other. I just did not have an example of it, but it was always there. I have a code that is primitivist. It accepts all integers, and this will be a problem soon. Yeah. So, sorry. Okay. There is something here that I find quite interesting, is that once you start doing at least this, at least parameterized testing, you start to say assertions that keep coming because your code is primitivist. Like, oh yeah, the score is between 0 and 300, and you can put this in every test you do, because the score is always between 0 and 300, right? All other values are invalid. And once you start seeing those things repeat themselves, you start looking at a code and say, oh, maybe this should be an invariant in my code, right? Maybe I should not accept to create an invalid at all. This object should not be able to be created with an invalid value. Yeah. Welcome to domain invariants. So, one invariant, a single invariant, can have several properties. But a domain invariant is just something that you think is always true in your domain. Yeah? Something that you bet in is always true in your domain. This should never happen. Okay, then you can put that in your invariant. This should never happen. Yeah? And you have, oh damn it, you have lots of those. We can kind of, with the whole problems we have in the beginning, we kind of lost some minutes there that were precious. So I kind of have to rush into things here. I'm really sorry. Let's talk about property-based testing. Now, this is beautiful, right? Or not? So, assumptions. When I assume something it fails, the test is just ignore it. The test doesn't fail. Okay? Don't get too close. Don't get too hang up into what does this into the unfamiliarity of this. Also, this is an awful test, but I did it on purpose. I just starting to show you how to do less wrong than you do today. Not to be how to be perfect, but how with very minimal effort you can pass from a test that is not very good to a test that is less problematic. Yeah? That's all my goal here, is for you to do this Monday. Not for you to do the perfect kinds of property-based tests, but how to refactor your current tests towards something better using property-based. Yeah? There's a very different goal. Because if you really wanted to create awesome property-based tests from scratch without your legacy, you have good presentations by John Hughes that created QuickCheck. But the problem people usually have problem solving is, oh, but I have this huge legacy code base. How do I do property-based tests with them? This is the problem I try to solve in this presentation. Okay? So, what it does here, it generates several inputs, and if it passes my assumption, it should pass in my assertion. A property is true to in a context. So I put in a context. It should be true if this is true. This should be true if this is true. Yeah? That's what I do in property-based tests. I say, well, generate random stuff. And if you want to generate it have this behavior, then when you call my function, it should have this behavior. Yeah? And when it finds you wrong, it means that either you have a bug in your code base or you have a bug in your understanding of the domain. You don't know yet. Maybe your bet was the wrong bet. Or maybe your code is bugged. So, I have to go quick on this. So, what I'm trying to do is, you may feel that this seems strange, that just generate a random input is less interesting than put some specific inputs, because now you're testing, you know what you're testing. Don't fall to that. What you're generating is the parts you're saying I don't care about. This should be always, no matter what it is, this should be always be the behavior I want. Yes? That's what you should generate. So what you're saying is, I'm pretty sure that this is always like this. And if you are, you can bet. And the framework can try to find your counterexample. Yep? Okay. So let's go back to our production test. I'm saying, in the prescription, I want to be alerted when I have a too high dosage. In the prescription, you have several things, a whole document with several things. And what I'm saying is, okay, if the dosage is too big, I should have an alert, right? And what I tell myself is just this that is important. Well, I'm wrong. My understanding of this business rule is wrong. It's very wrong. Because I could have a very small dosage and just put 15 times a day and still kill you. Yeah? When I did my test and I assured myself that I should have all cases covered, this will work. If I execute those tests, they work. And I'll have 100% coverage. So test coverage, really, I don't use them. So I will have 100% coverage. My test is called, etc. Everything is good, fine, and it's still bugged, because I'm still with a false idea of what it should work, how this should work. Okay? If I do this with property-based tests, I just do it ugly, right? What this means is, you see this? I just want any patient, right? This is the line I found important. I just want any patient. So it's fixture, right? Well, if it's a fixture, I could replace the name of my patient and age and the name of my drug, everything that is not the thing I thought that was important. I can replace it by random, yeah? I could. And if I replace by random, then I'm doing property-based tests. Yeah? Okay. So if I do that, if I do specifically that, I end up with this is an awful test, and I end up with this other awful test, right? That has 2 lines. Those should be greater than 3. If that's the case, I should have my alert that my prescription is dangerous to my patient. Yes? Well, strangely, when I do that, it fails. And it gives me a counterexample. I say, oh, I tried this one, and it did not have the behavior you asked for. And now I have to find, now I have a counterexample. I can put that in a specific example-based tests, and it will still fail. And I can use that to find, okay, did I understood something wrong, or do I have a bug in my test? Is one of the 2. What I mean to say is, property-based tests, when they go red, what they say is, there is a bug in your code or in your understanding. But when they go green, they are not saying everything is good. They are only saying, I did not have you this time, but someday I will. That's all they are saying. Okay? But you know what? Example-based tests have the same behavior. When you do a test like this, when it goes green, it is telling you the exact same thing. It's not telling you it's good. It's telling you, I have not got you this time, but I will have you someday. It's just that each time it tries the same thing. So it's not very smart, right? Whereas if you do it with random values, then now it has a chance to have you someday. That's all. You lose nothing. You just gain things from doing this approach. Okay, to be fair, some things you cannot do with property-based tests. For example, in the bowling itself, spares and strikes, you cannot really do them without putting the solution code into the test itself. And you should never do that, right? So you cannot really do them. You can do some things, like say, oh yeah, if I do a spare, I should have a higher score than if I don't do a spare, right? This is a property. But it's not the whole business rules of my problem. So I still have to mix and match some property-based tests with some example-based tests. It's not perfect, but everywhere where you can do it, you should probably do it. Yeah? You have a smaller test that documents your code base, documents your business rules, that makes it easier to do your archaeology, and that tests more. Is a net win several levels, right? So you should probably do them. Now, there are 4 different ways I do property-based tests in my real life. One, I have shown you, compressing tests together until they are a property, yes? This is valid. This is one way I do this. There is a second way I do this, is where I get a business rule. Okay, I get a business rule from my domain expert. He said, this should always be like that. And I say, okay, I create a property-based test. It's too big, right? So it will be read for a lot of time. I do TDD inside it. I have several example-based tests. Do TDD inside it until the property-based tests go green. And then I see whether do I erase or not from my example-based tests. This is a completely different way of doing this. A third way I have of doing this is to ask questions to my code base. The code base knows things that I don't know and that my domain expert don't know. So I just ask questions to my code base. Is this always the case here in my domain? And the code base answers its questions. And I can compare those answers to the ones of my domain expert and have a debate. And I do this a lot. And a third usage of property-based tests is in legacy code base, fourth usage I have, is to do characterization tests. I don't know what this class is supposed to do at all. So, so I just invent random shit and see this behavior. And it's way easier to do with a random generator than by hand. Okay? And I advise you to do it. Thank you very much. Hello. I do have time for some questions, apparently. I rushed everything out, but now I have, apparently. So, yeah. No, I don't say often. I just say that at some point, there are some things you cannot do this. You have really, in real life, you have a huge amount of business rules that you can just put in properties. A huge amount. You have this all. You all have a code base where you have business rules where you can do this. Your business rule user are a domain invariant, and so those domain invariants most of the time can be translated into several properties. Sometimes a single business rule is several properties. That happens, but you can probably do this in your code base today. Okay? Yeah. I don't know. My experience up until now is to have not have that many tautological. You always have you always have a percentage of a code base that will become tautological, and should not do that. But you usually have a small a subset of a code base where it's not the case. I usually have a question here that comes a lot is, okay, Romeu, but what you do here is that each time it executes random input 100 times. My tests today are slow. Very slow, like takes minutes to execute the test cases. I really don't want to execute them all 100 times each time I execute my test case. That's not really something I want, right? This is something I get a lot here. And so my usual answer to that is, the real answer I should do is, well, you have problems in your tests and you should refactor them. But that doesn't help you at all, right? You know that. So if you do not pay, you will not pay the whole the technical debt you have in your tests like that, right? So I will give you a compromise. If you have one test that takes several minutes to execute and is very slow, yeah, do a property-based test and change the configuration to, instead of trying 100 times, it tries once. You have the same speed as today. But each time you execute a whole test case, you try something a little bit different. So you'll be a little bit better, yeah? I'm not saying it's good, it's awful. Like almost everything I've shown you is awful. But I'm trying to give you compromises to do that today. Yes? Oh, also, one question I have a lot when I do this is, well, Romeu, I have a build pipeline with Jenkins. And it builds my code base entirely. Each time I have to do a new version, right? What you're saying here is, I could have the situation where my dev in his machine, in her machine, is having a green everything, and then he'd say, well, I commit this, And Jenkins built it, and now it's red. And what I usually answer is, yeah, this is the same situation that you would have if everything was green, and what Jenkins is building, someone from QA comes and say, hey, I found a bug. It's the same situation. You can only do two things in this situation right now. Either you say, stop the process, we have to fix this, or you say, okay, I'll note this and I'll release anyway. Right? These are your two options. Property-based tests are not changing those two options. Okay? Some bugs may take a while to find. I use this in production, and sometimes you find the counterexample like one year later. You execute every day. You execute your tests, and randomly he ends up finding a counterexample way later. Right? It can happen. It can happen. It can really happen. And it surprises you. I say, "Oh, damn it! I have not seen that." It's still better than not finding at all. Right? Yep. Yeah, shrinking. Yeah. I just thought that I did not have the time to speak about shrinking, so yeah. So ScalaCheck and this thing I used here too does shrinking, right? When he finds a counterexample, he tries to cut the counterexample in smaller slices to see if it still fails, and tries to give you the smallest thing he finds that still fails, right? And it's awesome because it helps a lot to understand why it failed. For example, in real life, I use property-based tests to do in tests and integration tests and very high-scale systems integration tests. And I have done some property-based tests where I call URLs with random JSON inside it. And in the beginning, I use a framework that did not do shrinking. If you have the option between two frameworks, like ScalaCheck and something else, do the one that does shrinking, right? I use one that did not do shrinking, and so I just have this huge string with several Korean and Japanese characters inside it. And I was like, oh, that's probably a short-set problem. And it was not. Thank you very much.